Right, good morning everyone. Everyone hear me okay? Yeah? Right, so thanks for coming along today. My name's Andrew.nicholls. I'm Head of Conversions at S. Jones Containers. We've been specialising in engineering processes for some time now, working with different industry leaders across multiple sectors. S. Jones have been manufacturing battery stores for about 6 to 7 years. One of the difficulties we find is that customers have no guidance. So they don't know what is required from them. They come to us asking how far away from the building does it need to be, how much human interaction the units are having, and that depends on the safety features required. What type of chemical makeup, that can have effect on the safety features as well. There are many questions surrounding this. We can offer a full range of safety features from fire suppression, gas detection, ATEX gas extraction, fire ratings. However, budget is a big thing for companies, and not everyone has the large budgets that come with all the safety features. So with no guidelines on this, we find we are designing battery storage systems based on budgets rather than safety. And then it's down to insurance and risk assessments to basically give them the specification that's required. I'm joined today by 3 experts in their fields. They're going to talk us through some of the dangers, the impact the batteries can have on companies, and more importantly, people and their families. So, first up, I would like to introduce you Giuseppi Capanna, from Product Safety Engineer from Electrical Safety First. Giuseppe and his organisation are leading the charge of getting the much needed legislation in place. Giuseppe has been involved in getting bills in the House of Commons and Lords, and was on a call recently to provide advice to Parliament, meaning he was unable to attend one of my team's meetings. So I think we can let him off for that. Giuseppe, over to you.
Thank you. Good morning, can you hear me okay? Okay. So, thank you for giving me the opportunity today to talk about electrical safety first and our work on online marketplaces and battery safety. As we said, I'm Giuseppe Capanna, Product Safety Engineer for Electrical Safety First. So, we're going to talk today about 2 of our recent campaigns. 1, the need to regulate online marketplaces, and 2, how to reduce the number of fires and injuries caused by lithium-ion batteries in e-bikes and e-scooters. So, online marketplaces are a hotbed of dangerous products. There's a lack of regulation, and third-party sellers on these online marketplaces are not currently regulated. They're not recognised as actors in a traditional supply chain, so it's very difficult for enforcement agencies to prosecute when problems occur. But to provide some context for today, it's important to note that Electrical Safety First are not campaigning to say that e-bikes and e-scooters are dangerous. In fact, we see them as a vital role in getting the UK to a net zero agenda. In the UK, the e-bike market is worth over £300 million. However, at the moment, there's no guarantee that if you buy an e-bike or e-scooter, that product will be safe. And the reason for that is because at the moment, online marketplaces and anyone building an e-bike or e-scooter only has to self-declare that product is safe. So you or me could build a battery and we could declare, yes, it meets all the safety standards. Yet the problem is, quite often that isn't the case, and that's why we're finding so many of these substandard products being sold and brought into our homes. So lithium-ion batteries are not inherently unsafe. If you buy an e-bike from a reputable manufacturer and it's maintained properly and stored correctly, it's undoubtedly a safe product. On the other hand, on online marketplaces is a popular place for people to shop. But what we're finding is that in these online marketplaces, we're often finding these unsafe products. And many investigations by Electrical Safety First and by the Toy and Hobby Association and which have found countless unsafe products available on these sites. And that's something that can't continue. So now I'd like to introduce you to someone called Scott, who lost his whole family due to an e-bike or e-scooter and e-bike fire in his home. So I'm going to let Scott tell his own story, but it's important to note the human cost of some of these fires.
It was about to be one of the best times of our life. Our little son Oliver was about to finish play school. He was about to go into full-time school. That meant Gemma could finally get a job and we could start actually having a decent life, because ever since Lily was born, Gemma had become a full-time mum, and all our lives were literally about to start, and it just all got snuffed out in a night. Well, I've been working at M&S for coming up to 11 years, and I've been riding to work, doing it in the wind, the rain, the traffic, any sort of condition you could think of. I just thought, our lives are about to get easier now. It's literally just supposed to be a luxury item just to make all our lives easier. If I'd known that it could cause this, I never would have bought it. We were woken in the night by an almighty bang. The floor shaked, the house echoed. By the time I got outside my bedroom, I could see the glow of the fire. There was flames coming up the stairs like a flamethrower. I've never seen anything like it. I was terrified for my children. I knew something had to be done, so I jumped out the window. I told Gemma I'll be back in a minute. I basically got into the back door and the entire hallway was engulfed in flames, and I could just see this massive glow just right above my bike. Everything was on fire. So I ran back out to the back garden and started calling for Gemma and the kids to jump. The last thing I ever heard from my girlfriend was, "We can't get out, we're stuck." I called for her about 2 more times, but I never got an answer from her again. At that point, I collapsed on the floor in tears. I closed my eyes after that, and I woke up 4 weeks later in hospital. I'd been in a coma for 4 weeks, and no one had made it out of the house.
Since 2020, 15 people have lost their lives to e-bike and e-scooter fires. And we extend our sympathies to those who have, been affected by those incidents. Last year, 3 coroners issued prevention of future deaths reports, urging the government to act on the urgency needed to provide regulation and to stop these fires. Unfortunately, these are not isolated incidents. 180 constituencies have found that there's fires in their constituencies, and last year 160 e-bike fires were attended by London Fire Brigade. That's a fire every 2 days, and that's why we need to get a regulation. So our campaign asks for 3 things. Third-party regulation for e-bike and e-scooter manufacturers to make sure that they have to get their products tested before they put the products on the market. We're asking for markings on batteries so that batteries aren't entering the waste stream. And we're also asking that we improve the charging standards that are in current standards for e-bikes and e-scooters. So at the moment, you can buy a charger that charges a battery and it can overcharge the battery, and that's why we're finding many of these fires from these online products that can cause fires. So thank you very much.
Thanks, Giuseppe. I think we can all agree that how serious it is when these things do go wrong. Next up, we have Dr. Simon Jones from Warwick Manufacturing Group and the University of Warwick. Simon's experience in battery R&D second to none, and working with him at Warwick has helped us develop some truly safe systems for storing and testing lithium batteries. As he started to study the behaviour over many years through testing himself, it does help us and other industries know how batteries react. It is quite ironic, however, that he studied batteries and provided safety solutions on them for so many years to prevent fires, but he spent his whole career starting fires and blowing things up. So obviously all for science and all that stuff. So Dr. Simon Jones.
Yes, hi everybody. I'm Simon Jones. What I'm here to talk about today is really not how battery fires start. I'm here to talk about what kind of fires they are and the kind of problems we have extinguishing them. So there's a lot of myths out there to do with lithium-ion battery fires, and I come across them all the time. So people online saying, oh, the fire's temperatures are over 2000 centigrade, it melts steel. They're full of lithium metal, and there's a quote there from a guy who ought to know better, saying you can't put water on lithium-ion battery fires because you'll make the lithium metal react and you'll create a worse fire. Also that you can't put water onto a lithium-ion battery fire because it will give you an electric shock. And in actual fact, there are no recorded incidents of that ever happening. The thermal runaway kills the battery extremely quickly. And even if it doesn't, the water will take the current down to ground straight away. Also, people saying that it takes 50,000 litres to extinguish need to get a bit closer. 50,000 litres of water to extinguish a car fire, and the reason for that is because cars are actually quite waterproof. The fire's underneath the car, it's got a roof, it's got the cabin, and the battery pack itself is waterproof. You don't need 50,000 litres, you just need the water to be in the right place. So in reality, battery fires, the peak is about 1200 centigrade inside the battery pack. It'll melt aluminium, it won't melt steel. The actual flame temperatures that you see outside the pack are actually quite typical of ordinary fires. They're probably about 700-800 centigrade. I'm going to show a video, which hopefully will come on now. Yeah. This isn't one of my tests, incidentally. Our safety procedures are a bit better than this. What you're seeing there is white vapour, not smoke. That's explosive vapour, that's the fire. Very, very quick. The reason I wanted to show you that as much as anything is to show you how quick it is, how fast it develops. It goes from absolutely nothing to a high temperature torch fire in seconds. I'll just pop back to this. So the white vapour is not smoke, it's an explosive mixture of the vaporised electrolyte. And also, please bear in mind, the smoke from lithium-ion battery fires is toxic, very toxic. So very important to stay out of it. Whether that vapour cloud explodes or not depends on how it mixes with the air. So some of you may have heard of something called vapour cloud explosion. That's always a risk. Very frequently doesn't happen because the explosive mixture is wrong. There's not enough oxygen, or it hasn't mixed with the oxygen, so more often you get a fire. But if you do get the vapour cloud explosion, it's definitely something to worry about. It's not like a hydrogen explosion, but it's enough to destroy structures. So next I'm going to talk about a little case study. I warn you now, I personally found this extremely distressing. This was a factory in South Korea. Worth noting, this is not actually a lithium-ion battery fire, it's a primary lithium cell fire. And that means that the batteries were fully charged right from the very beginning. They weren't rechargeable batteries. They started their life at 100% state of charge, and that's one of the reasons why this was so dangerous. We don't know what started it. Might have been a faulty cell. That video's running now. Again, see the vapour. Extremely quick to develop. And just watch that smoke layer, or rather that vapour cloud layer coming down. And that's where I like to move on, because unfortunately all of the people you saw there died. 23 people died in that factory. The key points for me is the extremely rapid fire development. It went from being of no concern whatsoever to killing 23 people in about a minute and a half. which is really something you need to be very conscious of when you're talking about strategy, training, firefighting, because the only way those people stood any chance of surviving that event is if they had run like hell at the very beginning. There is no way that that fire could have been fought by individuals without full breathing apparatus. So for me, the most important thing there is if you're responsible for a facility, obviously that's an extreme case, please don't train people to try and fight these fires. People should leave immediately. The other thing I want to talk about is not being that guy. I've worked in passive fire protection my whole career, so well over 30 years now, and I've developed and sold an awful lot of products. The problem we have with lithium-ion battery fires at the moment is there are very, very few standards for actually carrying out tests. So the message I want to send out today is please promote the requirement for independent testing, for research, and for certification schemes for fighting these fires. Because otherwise we're all flying blind. We're trying to do our best, but it's very hard to sell a fire protection product in this market at the moment for this particular application, because it's very hard to prove that it works. So just to conclude, most important thing for lithium-ion battery fires is evacuation, which Giuseppe also covered. Most important thing is to get the people out as quickly as possible. Leave fighting fires to the professionals. Also, consider the possibility that letting something burn may actually be the best thing. If you think back to the first video I showed with the white vapor, when the battery is emitting white vapor, it's the battery burning. When that white vapor stops and you start to get black smoke or dark grey smoke, that means the battery fire is more or less finished and you can put it out. So wait for the white vapor to finish, then go in and try and put out the fire. Don't try and put it out when the battery is burning, because you probably won't be able to, and it will be over much quicker if you wait till it's done and then put out the fire that's a result of the battery fire, not the original battery fire. To control and contain, if you need to, water, fire blankets work pretty well. There are other cooling agents that people are developing that I'm optimistic about, but again, it's very hard to prove that they work because there aren't any standards. Worst case, a lot of water directly on the seat of the fire will help a lot. It's the best cooling agent there is, and it's readily available. And that's all I have to say. Thank you very much.
That's great. Well, thank you, Simon. I'm sure all of that is very useful to a lot of people, to be honest. So the final speaker today is Mr Chris Miles. He's the Commercial Director from Fire Protection Agency. Chris and his team take into all considerations to do with risk insurance when it comes to working with and storing batteries. Thankfully, organisations like the FPA are out there to provide companies with advice. Chris is here today to give advice on how to work with them, as we know how hard it can be commercially. So, Chris, over to you.
Good morning, everybody. Thanks, Andy. So yeah, just a quick 5 minutes really to explain what the FPA's involvement in this and how that can support you. The FPA has a research function which looks at kind of new developments that are needed to fight risk in its many forms. One of those is the emerging, you can call it that, battery fire in battery industry, which obviously results in what we've just seen in the last two speakers. Unfortunately, I don't have any kind of attention grabbing or sexy videos or anything like that. Pretty dry, so just bear with me. Part of the Fire Protection Association is a group funded by insurers. Some of the main insurers, most of the main insurers fund this. It's basically, I've heard it called as a crowdfunding research program called Risk Authority, and you can see that up there. So Risk Authority, and part of their job is to understand the risks involved in fire safety in this case, and to help people become aware of that. Part of our role is to disseminate that information, which we do in a number of ways, one of which is our monthly journal, which we've reprinted a lithium-ion special there. But pertinent to today are these two need-to-know guides, RE1 and RE2, and really all I'm going to do is take you through some of that, some of the content in there, and really just highlight what you should be thinking about, given what we've seen from Giuseppe and from Simon, when we get in the situation of having battery storage, be it a scooter or a conglomeration of a number of other batteries together. I'm sure if we need copies of the slides afterwards, you can get them, but I put a lot of references there for documents which are there to help you understand the needs and what the risks are, in addition to our RE1 and RE2 guides. Both the previous presenters have mentioned that legislation is lagging behind where it needs to be, and we don't have a you shall do this, you shall do that kind of environment for storage of batteries, even down to e-scooters, but also on a larger scale. There was a recent research project document on the left conducted where that looked at guidelines that were available across Europe, across the States, even to see what we could learn from them. That produced, or that referenced, two documents for the UK, but also said that there aren't any legislation rules that we should be following. The first document's National Fire Chiefs Council, basically just be aware there's a risk with batteries, and the second one's about health and safety of batteries, but not really fire safety issues. There's certainly nothing embedded in our regulations that says do this with batteries. You probably can't see the table on the left, but it's basically the growth of a fire, like Simon showed, and there's various stages of that fire where we could act on it and mitigate what happens to that fire. If it's in a self-contained unit, for instance, it might be a developing fire, but it's going to go nowhere. So there are various points that we could do, that we can put in place that would help us deal with batteries in case there was a fire. I don't intend to read through all of the slides. As I say, you can find this information, a copy of the slides afterwards, but there are things to do to mitigate a large fire. Keep it in a small storage area, keep it in a sprinklered storage area. That will help. It might not help with the vapor stage of the fire, but once you get beyond that, then it will stop the fire growing beyond. If it's not in a sprinklered area, then put it in a contained area away from everything else. Smoke detection is a really good idea in the vicinity of battery storage. So if we get an incident like we've seen, then we know early on that we can do it. So this is just picking up from what our documents have said, and each of the RE1, RE2 guides, which are available online, go into a bit more detail if it's in a commercial environment where we've got equipment that's building energy storage systems. They get known as now bigger storage systems for use of a building rather than just a scooter or something. So BESS systems can be bigger. We're all kind of going towards that probably unachievable net zero goal, but we're moving towards it, which means we're putting batteries in our houses, in our residential units, in tall buildings. There are major risks with doing that, but there are things we can do. So really all we're doing here in the Fire Protection Association and risk authorities, highlighting these are the risks, these are things you can do. And while there's no legislation to comply with, if you use best practice, if you do what you can to the best of your ability, then you're probably doing more than enough to satisfy you or the regulator or somebody afterwards to say, why didn't you do that? Why didn't you do this or the other? I guess my message is there are things we can do which are listed in our need to know guides, which can help you if you've got some level of battery storage in there. And any questions that you've got, please feel free. If you want copies of the documents I've talked to, come and see me and we'll arrange that. Thanks a lot.